So last time we have studied about the wave nature and particle nature of electromagnetic radiation. We have seen that Planck's electromagnetic theory, how quantized energy of photons are given by E equals to h nu, relationship between nu, speed of light and wavelength. And then we have seen photoelectric effect, Einstein photoelectric equation, how electromagnetic radiation causes ejection of electron from the metal surface, from the frequency of radiation incident on metal surface we can calculate kinetic energy of ejected electrons. So we have seen all these things. Now today I am going to discuss difference between orbit and orbital. This is very important. So when we say orbit, then orbit is a circular path. When we talk about atom, then in atom basic model that we have understood till now is that in atom there is nucleus and around that electron revolves. So electron revolves on a circular path and that circular path is known as orbit. But when we talk about the orbital, remember that this orbit is based on the particle nature of electron, and when we talk about the orbital, this orbital concept is based on wave nature of electron. In wave nature, we will assume that electron is like a wave, like a cloud, and in particle nature, we assume that electron is a particle, it has certain mass and momentum. In wave nature, we assume that electron is a wave, so it has all the properties of wave like wavelength, frequency, time period. So when we talk about orbit, it is mainly based on particle nature of electron. When we say about orbital, it is based on wave nature of electron. So here we have to discuss the difference. So first difference is that the circular path on which electron revolves is known as orbit. But when we say about orbital, orbital is three-dimensional space around the atom where probability of finding electron is maximum. This is based on quantum mechanical concept, and in quantum mechanics everything is explained on the basis of probability. There is no certainty in quantum mechanical model. There is always probability. So orbit is a circular path on which electron revolves, while orbital is three-dimensional space around atom where probability of finding electron is maximum. Second one, when we talk about orbit, it is based on particle nature of electron, so electron revolves on circular path, and we know that circular motion is a planar motion. So in orbit, planar motion of electron takes place, but as the orbital is the three-dimensional space where probability of finding electron is maximum, so this orbital indicates three-dimensional motion of electron. Now next is orbit. Orbit concept of orbit is based on particle nature of electron, that already I have told you, and orbital is based on wave nature of electron. If we talk about the shape of orbit, already in the first point you have seen it is circular path. So shape of orbit will be circular. But when we talk about the orbital has different shape. In the next video lecture we will study about the different shape of orbitals. For example, if we say about s orbital, it has circular shape. If we talk about p orbital, it has dumbbell shape. If we talk about d orbital, it has double dumbbell shape. So different shapes are there for different orbitals. In case of orbit, shape is fixed, always circular, but in case of orbital, different orbital has different shape. Next point is, in case of orbit is not directional. Whenever we say circular path or circular shape, in that circular shape there is no definite direction. So orbit is not directional while orbital is directional, except s orbital, which is circular in shape. Rest all orbitals are directional in nature. Next is maximum number of electron. The maximum number of electron which any orbit can accommodate is 2n square. So from this rule, first orbit will have 2 electrons, second orbit will have 8 electron, third orbit will have 18 electron, fourth orbit will have 32 electron, likewise. So electrons in each orbit is different. First, second, third, fourth, fifth. When the number of orbits increases, number of electrons also increases. But when we talk about orbital can accommodate is 2. That orbital may be vacant, maybe 1 electron, but the maximum number any orbital can accommodate is 2. So in case of orbit, maximum number of electron in any orbit is given by 2n square. This is maximum number. May be less than this, but maximum will be 2n square, while maximum number of electron in any orbital is always 2, not more than 2. Less than 2 is possible, but maximum number of electron in orbital will be always 2. Quantum number. Quantum number is mathematical solution of Schrodinger wave equation, which on solution gives 4 quantum number. With the help of quantum number, we can get complete information of all electrons in an atom. And what are that complete information? That is shape, location, energy, type and orientation of orbital. So once we know the 4 quantum number, we can explain about the shape, location, energy, type and orientation of orbitals. So now we are going to see what are those 4 types of quantum number. So the first quantum number is principal quantum number. Principal quantum number is represented by small n, where n equals to 1, 2, 3, 4 or any integral value except 0. This 1, 2, 3 is also represented by K, L, M, N, O, P alphabets, which represents the number of cells in any atom. It represents number of cell. If I say 1, n equals to 1, this is cell number 1, or this can also be said as K subset, K cell. If I say 2, then number of cell is 2, that will be M. If I say 3, then number of cell is 3, and like this. So n represents number of cells. It gives average distance of electron from the nucleus. This n value gives us that electron is how far from the nucleus. If n equals to 1, then electron is very close to the nucleus. If n equals to 2, then electron is little away from the nucleus. So with the increase in number of n value, distance of electron from nucleus increases. That's why here this point is written. It gives average distance of electron from nucleus. So with the help of principal quantum number, we can get an idea that how far electron is there from nucleus. The last point is, it completely determines energy of electron in hydrogen and hydrogen-like atom. Whenever we say hydrogen-like atom, means the system in which there is only one electron. So for one electron system, we can determine its energy completely. So from principal quantum number, these facts we can describe about the electrons. Next quantum number is azimuthal quantum number. Azimuthal quantum number is represented by small l, and its value is n to n minus. Azimuthal quantum number is represented by small l. Its value is n to n minus 1. Number of subcells present, it also indicates number of subcells present in main cell. As well as with the help of azimuthal quantum number, we can calculate the angular momentum of electron present in any subcell and shape of various subcell. So let's summarize. First, it is represented by small l. Its value is n to n minus 1. Number of subcells present in main subcell, it gives number of subcells present in main cell. It also gives the angular momentum of the electron present in any subcell and shape of various subcells. In this example, we are going to see that how we can determine the value of L with the help of principal quantum number n. If principal quantum number n is equal to 1, then right now we have studied that value of L will be 0 to n minus 1. So if L equals to 1, then value of L will be 0 and 0. So 0, value of L will be 0. When the value of L is 0, then it is called S subcell, and shape of S subcell is spherical. If value of n is 2, then there will be two value of L, that is 0 and 1 from the formula L is equal to 0 to n minus 1. From this formula, n will have two value 0 and 1. For 0, subcell will be S, and for 1, subcell will be P. If n equals to 3, then L will have three values 0, 1, 2 by using the same formula, and will have three subcell as P and D. If n equals to 4, then L will have four values 0, 1, 2, 3, and there will be four subcells as P, D and F. So corresponding to 0, subcell will be S, corresponding to 1, subcell will be P. Similarly, corresponding to 2, subcell will be D, corresponding to 3, subcell will be F. So this is how we can determine the value of azimuthal quantum number with the help of principal quantum number by using the relation L equals to 0 to n minus 1. So here is the various shape of subcell. S subcell has a spherical shape, P subcell has dumbbell shape, and D subcell has double dumbbell cell. So from the azimuthal quantum number, we can determine different shapes of orbital. Third quantum number is magnetic quantum number. With the help of magnetic quantum number, we can withdraw following information. First information is that with the help of magnetic quantum number, we can determine number of orbitals present in subcell. How many orbitals are present in subcell, that we can determine with the help of magnetic quantum number, as well as orientation of orbital, in which what is the orientation of orbital, whether it is in xy plane, yz plane, zx plane. So we can determine orientation of orbital with the help of magnetic quantum number. Magnetic quantum number is represented by small m, and its value is given minus L to plus L. See one example. For example, if I write m L equals to 1, then m will have values minus 1, 0 and plus 1. So from here we can say that this L equals to 1 means orbital is p orbital. This is p orbital, p subcell. This one is our p subcell, p subcell. So from this magnetic quantum number value m, we can say that as there is three magnetic quantum value, there are three values of magnetic quantum number. For azimuthal quantum number L equals to 1, and these values are minus 1, 0 and plus 1. So there are three orbitals in p subcell. So with the help of magnetic quantum number, we can determine number of orbitals in subcell. Another example, if we take L equals to 0, in that case we'll have only one value of m, that is 0, and so it will have only one orbital, and we know that S subcell has only one orbital, for which the magnetic quantum number value is 0. Now next one is spin quantum number. Fourth quantum number is spin quantum number. This spin quantum number is represented by S, and This quantum number helps to determine magnetic properties of substance. Whether substance shows magnetic behavior, it gets attracted from the magnet or the magnetic field, get repelled from the magnet or magnetic field. All these properties we can determine with the help of spin quantum number. So how to determine spin quantum number? Whenever electron revolves around the nucleus, it has two kinds of spin. One spin is around the nucleus and one spin is about its own axis. Like Earth is revolving around the sun. So Earth has two type of spin, one about the sun and another one about its own axis. And due to this, there are two quantum number for clockwise and anti-clockwise. For anti-clockwise, this is represented as s equals to plus half, and for clockwise, it is represented as equals to minus half. So there are two quantum number, spin quantum number plus half and minus half. And when we write electronic configuration, whenever we show electron in orbital, we represent it by two arrow, one vertically upward, another vertically downward. This vertically upward indicates anti-clockwise spin of electron about its own axis, and this downward arrow indicates clockwise rotation of electron about its own axis. So it has two quantum number, spin quantum number plus half and minus half. So this was all about four different kinds of quantum number. We just summarize. Principal quantum number tells us about the number of cells, number of orbits, distance of electron from the nucleus, and energy of electron, energy of system, which is hydrogen or hydrogen like system. For that we can determine the energy. Azimuthal quantum number tells us about the shape and magnetic angular momentum of electron. When we say azimuthal quantum number, with the azimuthal quantum number we can determine number of subcells, shape of subcells, and angular momentum of orbitals. In case of magnetic quantum number, we can determine the magnetic behavior as well as orientation of orbitals. And the most important is, with the help of magnetic quantum number, we can calculate how many orbitals are there in particular subcell. But when we come to spin quantum number, it gives magnetic properties to any substance. So with the help of spin quantum number, we can determine magnetic behavior of substance. There are two types of spin quantum number, plus half and minus half. Plus half is for the rotation or spin of electron about its own axis in anti-clockwise direction, and minus half for its spin about its own axis in clockwise direction. So with the help of these all four quantum numbers, we can draw complete information about electrons present in atom. So these were the quantum numbers. This is very important topic. Prepare notes and try to solve question from NCERT exercise and in text.